Hello, hello! It's been a little bit. Marco here, and welcome to another Pencilmark video. This one here is from the 2025 Logic Masters Germany online qualifier, and I got 6th in that qualifier, which I'm pretty happy about. That's my best score so far in the 3 years I've been doing this, I guess. So I'm qualified for the 2025 German Logic Puzzle Championship, which is happening in about 2 months, and that'll be in person. And we'll just see how that goes. Last year I got 8th place overall in the German Championship, but I did win a round, which I was very happy with. So this puzzle here is a loop puzzle. I don't fully remember this, but I did solve it during the qualifier, and I think I did it with a bunch of trial and error, which might have been a little bit ugly, so today we're going to try doing this step by step fully logically. This puzzle type is called double or nothing, and it's a loop puzzle, and I really like loop puzzles, but this is a little bit more complicated. Instead of one loop, like just, I don't know, something like this going across the entire board, we actually have 2 loops. So something along the lines of this over here. I don't know. Basically, it's going to be 2 loops. And they are allowed to intersect on crosses. So on cross clues, you can have the 2 loops go like this. You can't have them bend, so this is not allowed. So you either have them intersect, or you just have them not use the cell at all. So this could be shaded or something. And these cross clues are either intersections of the 2 loops, or they are unused by either loop. I think that's about it. Oh yeah, and also all squares which are not marked with crosses here definitely have a segment from one loop or the other loop. So yeah, the crosses are basically double or nothing, and all the other squares are exactly 1. I think that's about it. Oh yeah, also you can't have a loop crossing itself on a cross, so you actually have to make sure that the 2 loops are different. Without further ado, let's start looking at this then, I guess. So the border does give us a lot of information here. And we do actually know that this cell over here, cells which are directly on the border, of course, they can't have a loop going like this through them because that goes outside the grid. So this will definitely be unused here. And of course, since there's definitely going to be stuff in the unshaded cells, these will end up going like this, crossing at this square. What I want to do is color the loops 2 different colors, but that might get confusing, so I'm going to do these in red for now, and when we know for sure what the whatever, I'll do one in red here and one in blue here. So we do see this over here. With these 2 crosses down below, we definitely have a situation where it's either this goes down, and then these will have to be the red loop going across, or these are essentially both unused and red loop goes down here, the blue loop goes down here. What's interesting here is that actually in both cases, we'll sort of have this bit happening over here. So we can actually do these lines for now, but we're not sure how this bit resolves yet. Over here, I guess we can have a situation where this cell here is not used and this red loop goes around. Well, if it does, then this would have to be shaded as well. And the blue could continue down here. Or we would have a loop crossing like this. Both of those are still fine, so I don't think we can progress anymore over there. Over on the bottom left, this cell here I think is definitely shaded. If this here, okay, this might not be the same red as the top right, but if this goes over here, if this is the cross, it would take 2 bits of the same loop. So we do have to shade this essentially. And then we do end up extending this. Now this cross over here has to be an actual cross. I'll correct the colors later when we get the actual colors. But yeah, this is an actual cross over here, because if this is also a shaded cell, it would mess with the loop connectivity, so we'd have to have something go through here and also something go through here, because both of these cells are used, and that just sort of breaks everything. So there's definitely a crossing that happens here, and I'll correct the colors to match the top right later. We can have this cell shaded, that's fine. We'd have to end up over here with this cell shaded as well. It can also have a crossing. In this case, we would have to extend... Oh, there's actually a break that happens here. If we have this crossing, we'll end up having to connect this lower loop segment over to this corner. And then both of these have to extend, and then they both sort of end up hitting this cross. Actually, we do have a case where this cell does end up having to be shaded. This is a bit of a weird bifurcation to make, but I guess bear with me. We'll have to go over here. This cell can't be an actual cross anymore, and we can just keep going on this side. This cell, because this is actually used by the loop, it does hit the cross. We do have to go up from this space here because these are 2 different loops. They can't connect. What I actually might end up doing is to use 2 different colors for this part here. So I'm going to go over this loop here in green. Let's do a darker green actually. Something like this here. I'll increase the pen size by a little bit so we can overlap it more properly. Yeah, let's do something like this here, so that this green is like, this is so ugly. Maybe I can fill tool this in. No, this isn't gonna work. Here. Okay. This is covered properly now. So this is going to be 1 loop, and this orange here is going to be, or no, it's more of a yellow. This is going to be the 2nd loop. And I do see a problem that arises if this cell over here is actually a crossing cell, because if these go across, right? This part here is the part of the yellow loop, and this part here is a part of the green loop, but they have to connect like this. So that's going to be a problem because it's 2 different parities. So green loop goes up, yellow loop goes, let me use color picker, yellow loop goes down over here. And now this cross is definitely a part of a loop, but I don't know which, so let's just do red for this again. Oh gosh, the colors are turning into a mess. Because if, again, like this is the same deduction we made over here. If this is blue, then the loop sort of splits off into 2 directions, and that's bad. if this crossover here is a part of a loop, we end up with this situation, and then these ends would have to, they can't connect over here anymore to this corner cell, so they would have to go up like this, but that sort of creates a self loop down here, which would be a third loop, which is bad. So we do actually have a shaded cell in this spot. The lines will connect out like so, meaning this becomes the loop we marked as yellow, and this other loop is the one we marked as green. Oh gosh, this is derailing with the colors here. We cannot shade this cell here because we also have the same sort of splitting loop problem here, so this is definitely a cross. We're going to use blue here for the blue loop, for the bloop, and red over here for this loop going down, and this red is actually going to end up connecting to the green. Okay, so let's make this blue part here yellow. And we'll make the red part above green. Because we'll know for sure that these are parts of the same loop now. Dang, this coloring thing was very confusing. But I think we managed an appropriate bifurcation down here, and that's sort of connected all the way to this on the edge of the board. Let's see if we can continue this up top. I don't think we can actually use this here as a crossing, because if we do green over here, we end up doing yellow over here, and then this corner needs to be occupied, so we would end up crossing the two different, or connecting the two different colored loops. That's bad. This here is going to end up shaded. And a weird deduction is if we end up shading this cell, we have to use this here as part of the loop, so this ends up happening here and that ends up happening. And then this end needs to connect to the rest of the loop, but it's sort of blocked off by these two bits and ends up self-looping. This here is actually going to be used by the loop. I'll just do this in blue for now. And then we either have this situation happening with this cell being shaded, or this situation happening with this cell being shaded. So we'll just have to see how that resolves. Down here, we have this yellow, which can't turn left because it would go to the green, so this definitely goes up one. It can go over here directly. We're not quite sure how this resolves yet. Oh yeah, of course. We do want to extend the screen out here by one. So I think I color picked wrong. Here, this one's going to be a lighter color. This matches better. And this is the part where I am stuck a little bit, because there's just, I guess, a lot of empty space here. This part over here, we still have our two cases that both still seem to work. Just imagine this is yellow. Those two cases both still seem to work. So we have to do something in the top left. I don't think this connection is going to be good. And this is probably a tough spot to see, but if we end up doing this connection and then we close this over here, we end up with a self loop over here. If we do the connection and go up one, we sort of have the same problem here with this cell needing to take something so it runs into this cross. And if we extend these up by 2, we have the same loop color crossing each other. So I think this has to go to the right, which is a weird deduction to make. This ends up going to the right and up, and then it goes to the left and up, sort of zigzagging to fill in the empty space, and now this here cannot be a cross anymore. I end up going up and here to use this cross. This goes up one more, to the right to just take all the empty space, and then we end up with this crossing over here. Now this other loop here is going to be the yellow. This extends out a bit more. And now if we end up shading this cell, yeah, we sort of have the same problem where it splits off into 2 loops, right? So we can't do that. This is going to be a cross. And if these connect, then this connection happens and then it's the same color, but we want it to be a different color. So this is going to take the across, the yellow, and the green is going to go down through this. And now we have to connect these 2 yellow segments. If the yellow segment here goes down, this yellow segment is going to go down and it's going to run into the green segment trying to cross through these. And finally, we have our resolution for the top right. These 2 crosses aren't going to be used. These yellows connect. And we've used all cross clues, so now it's just a matter of connecting the rest of the puzzle. So I think we can get rid of our blue from our color palette now. These connections are forced here, and now the green is looping over here. We can't connect these 2. We have to connect it to the right side. These will have to extend over here a bit. This connection happens here. We have this bit zigzagging. Yellow zigzags up to take this one space next to the double. This goes up. This has to escape here. And we are done. We've got our 2 loops, and they fully work out. This was a very tough puzzle, and I see why this was one of the highest point puzzles in this qualifier. This was a rough solve over here. I think I did this with a lot more intuition, but I'm glad this solve here worked out logically as well. I hope you enjoyed watching, and I'll try doing some other puzzles from this qualifier, including ones which I did not solve during the actual time here. But I really liked this one, and I thought it was a neat puzzle, and I hope to see some more double or nothing puzzles in the future. Anyways, that's it for me today. Bye-bye.